In this video, we will be exploring C++ arrays. Arrays are a fundamental concept in programming, allowing us to create and work with fixed-size collections of elements. Let's dive in and discover how arrays can be used effectively in C++. Let's start with array declaration and initialization. Arrays represent a fixed-size collection of elements. These elements are stored in contiguous memory locations, meaning they are next to each other in memory. It's crucial that all elements within an array are of the same data type, such as integers, characters, or floating point numbers. Arrays are zero-indexed, so the first element is at index 0. Here are some examples of how to declare and initialize arrays. First, to declare an uninitialized array of 5 integers, you write int numbers followed by square brackets containing 5. To initialize an array, you can assign values to it at the time of declaration. For example, int scores with size 5 is assigned values 95, 88, 76, 90, and 82 within curly braces. When initializing an array, the size can be omitted, and the compiler will infer it based on the number of elements provided. For example, a character array named vowels is initialized with the characters a, e, I, o, and u. Note that each character is enclosed in single quotes. Now let's explore how to access array elements. Each element in an array can be accessed directly using its index within square brackets. Consider an integer array named scores, initialized with the values 95, 88, 76, 90, and 82. To access the third element, which is 76, we use scores with index 2. Remember, arrays are zero-indexed, so index 2 refers to the third element. As shown in the code, you can access elements using their index. For example, int second score equals scores with index 1, which retrieves the value 88. To modify an element, you can assign a new value to a specific index. For example, scores with index 2 is assigned the value 78, changing the original value of 76 to 78. It's crucial to understand array bounds checking in C++. C++ does not perform automatic bounds checking. This means that the compiler does not prevent you from accessing elements outside the valid range of indices. Accessing elements outside the array bounds can lead to undefined behavior, memory corruption, or program crashes. Let's consider an integer array named numbers, with the values 10, 20, 30, 40, and 50. Accessing numbers with index 4 is valid and retrieves the value 50. However, accessing numbers with index 5 or numbers with index -1 is invalid because these indices are out of bounds. Such access results in undefined behavior. As a warning, remember that C++ does not automatically check array boundaries. Accessing elements outside the array's bounds can lead to unpredictable and potentially disastrous results, such as memory corruption or program crashes. Always ensure that you are accessing valid indices within your arrays. Let's explore how to iterate through arrays in C++. There are several ways to iterate through the elements of an array. The most common methods are using a for loop with an index, or using a range-based for loop in C++ 11 and later. Consider an integer array named scores, initialized with the values 95, 88, 76, 90, and 82. To iterate through the array using a for loop with an index, you can initialize a loop counter to 0, increment it until it is less than 5, and then access each element using scores with index I. Alternatively, you can use a range-based for loop, which simplifies the iteration process. This loop iterates through each element in the array directly, assigning the value of each element to the variable score. For example, the output shows each score printed on a new line using the index for loop, and then all scores printed on the same line using the range-based for loop. Let's discuss some common array operations. Arrays are often used to perform various operations on collections of data. Some common operations include finding the sum of elements, finding the minimum or maximum values, searching for a specific value, and counting occurrences of a particular element. Consider an integer array named numbers, initialized with the values 10, 20, 30, 40, and 50. To calculate the sum of all elements, you can iterate through the array using a range base for loop and add each element to a sum variable. To find the maximum value, you can initialize a max variable with the first element of the array, and then iterate through the array, updating max whenever you find a larger value. Now let's dive into multidimensional arrays. In C++, you can create arrays with multiple dimensions such as two-dimensional arrays, which are useful for representing matrices or tables. A 2D array is declared by specifying the number of rows and columns. For example, int matrix with dimensions 3 and 4 declares a 2D array with 3 rows and 4 columns. Elements in a 2D array are accessed using two indices, one for the row and one for the column. In the code, a 2D array named matrix is initialized with values. To access the element in the second row and third column, which is the value 7, you use matrix with indices 1 and 2. Iterating through a 2D array involves nested loops. The outer loop iterates through the rows, and the inner loop iterates through the columns. The visualization shows a 2D array with 3 rows and 4 columns. The element at matrix 1, 2 is highlighted, illustrating how to access a specific element in the array. Let's explore the relationship between arrays and functions in C++. Arrays can be passed as arguments to functions, allowing you to perform operations on array elements within a function. When passing arrays to functions, it's important to understand how C++ handles them. Here's an example. The function printArray takes an integer array and its size as parameters and prints each element of the array. The function doubleValues takes an integer array and its size as parameters and multiplies each element of the array by 2. When passing arrays to functions, C++ passes them by reference automatically. This means that any changes made to the array inside the function will affect the original array. As shown in the code, the main function declares an integer array named numbers, and then calls the printArray function to print the original array. After that, the main function calls the doubleValues function to modify the array, and then calls printArray, again to print the modified array. As noted, arrays are passed by reference automatically, and the size parameter is necessary since arrays lose their size information when passed to functions. Also, changes to array elements in functions affect the original array. Now let's compare arrays with vectors in C++. Both arrays and vectors are used to store collections of elements, but they have key differences. Arrays have a fixed size at compile time, while vectors are dynamic and can grow or shrink at runtime. Arrays are typically stored on the stack, while vectors are stored on the heap. Arrays do not have built-in size tracking, while vectors automatically track their size. Arrays do not have bounds checking, while vectors can provide optional bounds checking using the at function. Arrays have no built-in functions, while vectors have many built-in functions, such as push_back and pop_back. Use arrays when the size is known at compile time, performance is critical, memory constraints are tight, or you are working with C-style application programming interfaces. Use vectors when the size may change at runtime, you need built-in bounds checking, you need convenient methods, or you are engaged in modern C++ development. The code shows an example of using both arrays and vectors. An array is declared with a fixed size. A vector is created, and elements are added to it using push_back. The size function is used to get the vector's size, and the at function is used for safe element access with bounds checking. Here are the key takeaways from our discussion on C++ arrays. Arrays are a fundamental concept in C++, serving as fixed-size collections of elements of the same type. These elements are stored contiguously in memory, and arrays are zero-indexed. The size of an array must be known at compile time. When working with arrays, remember that you can access elements using square bracket notation, and there is no automatic bounds checking. Arrays can be passed to functions and can be single or multidimensional. Common operations include iteration, finding minimum or maximum values, calculating sums or averages, and searching for specific elements. Finally, consider modern alternatives like STD, vector for dynamic size requirements, and STD, array for fixed size with added safety. As a final word, arrays are the foundation of many data structures and algorithms in C++. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.